Hi, everyone. Thank you so much for joining this session. I'm very, very excited to be here today because, first of all, the topic of this live stream is very, very interesting for me. And I think for Microsoft, so I can speak really for the entire organization in this sense. I'm here with Mehrnoosh Sameki and Stephanie Lindsey. They are two program managers at Microsoft and they work in the Azure Machine Learning team. So I'm very, very excited to have them both as a guest. The topic of this session is going to be Azure Machine Learning, but specifically responsible ML, responsible machine learning. So we are going to talk about what are the different toolkits and open source also Python packages that data scientists and developers can use in order to make sure that they try to incorporate these responsible machine learning within their machine learning and AI solutions. I'm very happy to be here. As I said, my name is Francesca Lazzari. I'm a cloud advocate at Microsoft, and I will be running a few sessions this week on machine learning. So, but for today, let's get started, and again, let's talk a little bit more about machine learning, specifically responsible machine learning within Azure Machine Learning. So let's start with the first question for you, Stephanie. So can you please share a little bit more context on what responsible AI, artificial intelligence, is, and why Microsoft has decided, to invest more in this area?
Sure. Responsible AI is an umbrella term for many themes associated with the intersection of ethics and AI. Microsoft's 6 AI principles reflects its unique perspective on a set of important influences of AI technologies on society and people. 4 of those core principles are fairness, reliability, safety, security, privacy, inclusiveness, and they're all underpinned under 2 foundational principles of transparency and accountability. Enabling responsible development in AI technologies has been a real challenge as we move from research into practice. That was captured recently in a study by Capgemini Research Institute, where executives in 9 out of 10 organizations across the globe cited ethical issues with AI systems over the past 2 to 3 years. That included collecting personal patient data for healthcare without consent, as well as over-relying on machine-led decisions without disclosure for banking and insurance. They cited reasons for this being the need to act urgently to build these systems, as well as just not considering ethical issues when building these systems, and also just lack of resources and practical tools. So now there's a call across the industry for all technology creators that are building these AI systems to really build it in such a way that benefits people and engineer responsibility into the very fabric of technology. So overcoming these challenges and ensuring responsible development in AI technology is essential for the future so that AI and machine learning can be widely used. And that's why it's also critical for our business.
That's great. Thank you so much, Stephanie. Especially, I really like how you explain this issue also as an opportunity for businesses and companies and organizations in general. So it's really an area where you can see benefits not only from an ethical point of view, I think, but also from a business and from a societal point of view, which is great. I think that as a cloud advocate who focuses a lot on on machine learning and AI. Another term that I have been hearing a lot at Microsoft is, and not only at Microsoft, I would say in the machine learning community in general, is AI fairness. So there are these two very important concepts. I would say responsible machine learning, so interpretability of machine learning, meaning how we can understand our machine learning models better and why they're producing specific results. And then there is this other concept of fairness in AI. So can you tell us a little bit more about fairness in AI, and also what are some of the consequences, of unintended, I would say, consequences that can be created by AI systems that are not fair?
Sure. Yeah, it's a common misconception that AI is neutral or, in a sense, fair because they're built on these rigorous mathematical or statistical paradigms. But in reality, AI can do harm in several ways. One of those is harms of quality of service, and that's where our system works really well for one person versus another. A recent example is some publicly available commercial facial recognition software services ranked lower accuracy for women with dark skin color. Another example is harm of allocation, and that's where opportunities or information is withheld from specific groups of people. So that could be lower qualified male candidates could rank higher than more qualified female candidates for a particular job.
Yeah, this is super interesting again, and I'm very excited because I know that later during this session also Mehrnoosh is going to share with us a demo around this. So I'm also interested in understanding better what are the tools that actually machine learning scientists and developers can use to implement those type of solutions. So that's great. And so another thing that, in my opinion, it's very important to share with the audience today is how AI models can actually be can introduce these unfairness issues. So can you tell us a little bit more? Because I think that you gave us a great overview of what are the different issues, how businesses can look at those issues, and most importantly, how they can tackle them. But then there is all the other area that is more like about machine learning. So why AI and machine learning are so, can be like the main place where unfairness can be introduced. What's the main reason there?
Yeah, AI is really a product of human processes and decisions that create it, the data used to train it, and the environments used to test it. And so AI systems can behave differently and sometimes unfairly. One big source of unfairness in the machine learning lifecycle is with training data. And a lot of this is because the data comes from society and real world, and therefore it reflects our society's biases and discrimination against minorities and disadvantaged groups. So by ignoring this, AI can become a tool that perpetuates the unfairness that we observe in today's society. Today's society.
Yeah.
Just one other example I was going to say is, for example, we also see higher arrest rates for minorities for similar behaviors as we do with the white population. So building an AI system without compensating for these can just worsen the prejudice. And then the only other thing I was going to say is the lack of diversity in design teams can also lead to an undersampling of populations or various populations in the data set creation stage. But unfairness can happen anywhere in the machine learning lifecycle, whether it's data set creation, pre-processing, model training, testing, or deployment.
Yeah, this is again very important to understand because I think some people think that the biases, sorry, and unfairness can be created only at the data collection, data preparation part level of the machine learning cycle. But as you mentioned, Stephanie, actually there is risk from the beginning until the end. So from I would say from the data collection, data preparation until the model deployment, these risks are there. So this is very helpful. So in terms of tools and toolkits and packages that data scientists and developers can use in order to make sure that machine learning and most importantly the machine learning models that they prepare, they build are interpretable, so they can really unpack this type of solution, and also in order to assess the fairness level of their AI solution. So what's out there, and how Microsoft was able to integrate these within their own platform, Azure and Azure Machine Learning specifically. So Mers, can you tell us a little bit more about these packages and tools?
Yeah, absolutely. So our team has worked on two open source offerings. One is an open source offering that is for understanding models better, interpreting models, understanding how the model has come up with its predictions, performing what-if analysis, and trying to debug and understand it further and the errors that are happening within that. So that's one toolkit that we released as an open source, and it's called Interpret ML. So if you search for interpret.ml, or if you basically put it in the URL, you will go to the landing page, which takes you to the GitHub, and it's completely community driven. So if you're passionate about this topic from any perspective, research perspective, or you want to contribute to the UX of it, or the algorithms, the interpretability techniques there, you're more than welcome to join this community. So the reason why we started this is if you look for machine learning interpretability techniques, you're just going to be completely lost. There are so many techniques out there. Each of them is using different set of API calls, different data structures. So we really wanted to bring a collection of glass box models which are intrinsically interpretable and black box explainer that can explain any model under one roof, and provide the same set of API, a unified visualization dashboard, so it's just easier for you to try different interpretability techniques and even compare them and benchmark them and visualize the interpretations of it. So that's one toolkit that we have. And the second toolkit that we have is a machine learning fairness toolkit, which basically it consists of two different stages. Now, before I explain what these two stages are, I want to put this huge disclaimer out there that, as Stephanie touched, fairness is a very important socio-technical concept that has been studied by philosophers and sociologists, like a lot of different disciplines for decades and centuries. So, of course, we cannot come from the tech world and suddenly say that we solve the issue of fairness in any or unfairness in any form or shape, but there are certainly steps that we can take, at least to assess the harm of quality of service and the harm of allocation that Stephanie discussed, and understanding better and take steps towards mitigating that unfairness to the extent that we can, because of course some aspects of bias and unfairness cannot really be covered by technology and machine learning models. But the toolkit that we have consists of a set of metrics for assessing the fairness of your model, and also a visualization dashboard that allows you to experiment how your model has come up with its predictions with respect to different groups of people, say females versus males versus people of non-binary gender. I'll do a demo shortly. And also it has 3 state-of-the-art mitigation algorithms. A lot more will be added hopefully very soon. And these different algorithms can be incorporated into your machine learning lifecycle at different stages: post-processing, in-processing, and pre-processing, and help you mitigate the unfairness that you just observed in the assessment phase, and then also visualize the model pre-assessment and pre-mitigation and post-mitigation, and see whether you have improved the model with respect to its fairness, and also navigate the trade-offs that you see between fairness of the model and also performance of the model. Now, you mentioned, Francesca, Azure Machine Learning. So in case you're not familiar with Azure Machine Learning is basically a cloud-based environment that data scientists, software developers, and business stakeholders can use to train, deploy, automate, manage, and track machine learning models. So the great thing is about it is it can be used for any type of machine learning model, no matter if it's a classical machine learning model or more sophisticated deep neural networks and deep learning, supervised, unsupervised, different types of things. You can write code in Python or R, or you can opt in for the drag and drop module of it called Designer, which basically provides you with a bunch of modules, bunch of techniques built into different drag and drop modules, and then you can build a whole pipeline of your machine learning from data cleaning all the way to deployment just using this drag and drop. So at any level you want to get involved, there is something awesome for you there to experiment. So I really recommend you to check it out. Now, of course, the whole premise of Azure Machine Learning is about making it easy for you to train, track, deploy, monitor machine learning models. And a huge aspect of it for us was to incorporate both of these open source offerings that we have, InterpretML and Fairland, into Azure Machine Learning so that people have access to state-of-the-art interpretability, but also fairness assessment and unfairness mitigation algorithms, hoping that we can address the challenge that people had faced or had mentioned in the Capgemini study that was mentioning lack of access to practical tools is the number one challenge they were dealing with as they were sort of trying to navigate this challenge of building responsible artificial intelligence systems.
Yeah, so that's great. Thank you, Mers, also for the introduction to Azure Machine Learning Service. And by the way, I also put a link there in the chat because a lot of people were asking, about these. And I also really like the fact that you mentioned that there are so many different options for people. If you have, again, a data scientist or a developer or a business analyst, but you are still interested in machine learning, you can go there and see what are the best options, the best authoring tools for you. So that was a great introduction of at least the tool, the main tool that you can use. So you touched two very important aspects. So one, thank you so much for giving us a very good introduction of these responsible machine learning toolkits, both Fairlearn and InterpretML. And also the other one is Azure Machine Learning. That is, the main tool that we have right now on Azure to do machine learning, to build real end-to-end machine learning and AI solutions. So how can data scientists or developers use Azure Machine Learning to actually implement responsible machine learning solutions? So what's the connection there?
That's a very great question. So basically, the way that I always want to look at, or I would like to describe Azure Machine Learning is it has two different stages, development and deployment. Development is also known among data scientists as training time, and deployment, usually people refer to it as scoring time. Now, when you are developing your AI systems, you can, and via Azure Machine Learning, you usually either use the Azure Machine Learning SDK or the Designer, which is the drag and drop module that I was explaining. Now, the SDK version, which is in Python, basically what you can do is while you're training your machine learning model, you can also import the interpretability package of Azure Machine Learning to, at the same time that you're training, you can also explain your model, how the model has made its predictions, and then you can upload the generated explanations to the Azure Machine Learning and a new platform that was just released called Azure Machine Learning Studio, which basically keeps track of all your assets of your model training phase, all the way from data to models to experiments to your deployments and endpoints. Now, when you upload it to the Azure Machine Learning Studio, the interpretability dashboard that often you see in the open source will be automatically shown up in the Azure Machine Learning Studio. This way you can look at the generated explanations of your model. You can also share it with other stakeholders. And of course, this information will live there forever. So you can always load the models that you had trained like 5 years ago, 10 days ago, and look at the explanations and also use it for comparison to some newer models that you have trained. So same for fairness assessment. You can train your model, but at the same time generate the fairness metrics for your model and upload them to the Azure Machine Learning Studio. And that just becomes another metadata that is attached to your model asset. And then this way you can also see the Fairland Dashboard, which often you see in the open source, but now within Studio, which means that you can easily share it with other stakeholders and compare the fairness insights of multiple different models. Now, the other thing that we have implemented, and we will expand to fairness really hopefully soon, is at scoring time, you can deploy your model. And beside deploying your model, you can also deploy and productionize a scoring explainer, which means that at scoring time, at deployment time, you can call your deployed model and get the predictions for any brand new data point that your model sees. But also you can call the deployed explainer and get the explanations for your model. So a lot of people who are in Europe, who are working on companies that have branches in Europe, and we are aware of right to explanation that GDPR is emphasizing on. That's a great way for you to generate explanations at scoring time and basically provide answers to people whose legal status has been affected by the decision of an AI system.
Yes, that's great, and something that I noticed while I was experimenting a little bit with also, for example, the interpretable package is that you have this double capability both at the what we call inferencing time, but also at the experimentation level. So that's something that you mentioned, and it's also very important, especially for data scientists to understand. So this is great. So I know that both of you you are program managers at Microsoft. So this means that you also work a lot with external customers. So you not only build these wonderful services, products for Microsoft customers, but you really try to work together with them to see how they can work and eventually improve those tools. So what are some of the use cases, real-world scenarios that you have been working on with the customers, and can you share some of them with us just to get a more realistic perspective on the responsible machine learning world, also from our customers, Microsoft customers' point of view?
Sure. I'm happy to share two great examples.
Thank you,
Sure. One great example is Ernst & Young, who used Fairlearn to test their loan allocation models with real mortgage data, such as transactions and payment histories. And so Fairlearn was able to assess the fairness of those trained models and then mitigate the unfairness observed from a disparity of 7% between men and women for the accuracy of approving and denying loans, all the way down to 0.5%. Another great example is Scandinavian Airlines. They use InterpretML to identify and mitigate fraud for their Euro bonus loyalty program. And so data scientists are able to debug and verify their model predictions, generate explanations for their model behavior, as well as perform feature selections to gain confidence with their stakeholders for their machine learning models, as well as assist with meeting regulatory requirements.
This is very interesting, and I would say that some of the cases that use cases that I have been hearing about responsible machine learning, they come from different industries. So this really means that responsible ML, is not just useful for one specific industry, but I would say it's more like a vertical. So it's really trying to touch many different industries and many different customers. And another exciting thing, especially for me, is the fact that you are already starting working on responsible machine learning with many different customers. So this is not just something theoretical, conceptual that you're working on, but also you already are offering a few toolkits, and also you're working with the customers on these. So this is super exciting. So I would say that now we got a very good understanding of the context of responsible machine learning, fairness in AI. We also got a very good understanding of the different tools and a few customers or real world scenarios. So why we don't see a demo together? So in Azure Machine Learning.
That
I know,
sounds
Marcia,
great.
you have many different, demos. So tell us a little bit more about the demo that you're going to do today, and then please go ahead. You can share your screen.
Sure.
Yes, we can.
Real intent here is to simulate this experience and basically consider prediction of above $50,000 as approved on the loan and prediction of below $50,000 per year as rejected on the loan, just for the matter of these demonstrations. So something that I would like to really focus on here is both of these toolkits come to your scenario right after you have trained your model. So in this case, I have got the data and I get rid of, I basically transfer some information, like if, for instance, if there are some categorical and numeric features, I'm gonna send them through some transformations. I split it into train and test and do some coding, female, male, and also genders, races. We'll see how it comes handy, specifically in the visualization dashboard. It makes it a lot more readable. But then I apply all the feature transformations, and then my training pipelines become a pipeline where I apply these transformations on top of my features, either numerical features or categorical features, and a specific model that I have trained here, which just for the sake of simplicity, I trained the logistic regression. But it is worth mentioning that we support any model, no matter if it's a classic traditional machine learning model all the way to deep neural network models trained via PyTorch, TensorFlow, or Keras, as long as either your model has this .predict or .predict proba implemented that is conforming to the scikit way of predict proba, or you can wrap your custom prediction function into a wrapper that transformed its output into something that is conforming to predict and predict proba, then we can support it. So basically, either you're working with a scikit model or something that has that predict proba, which we easily support with no transformation needed. If not, you just need to have this very simple wrapper function and pass that wrapper function to us. So here I trained the model. Basically now my training pipeline becomes the transformation and the model training. And here is where the interpretability comes into the scenario. The very first object that I have to, so this one is based on SHAP kernel explainer, which I'm importing from our open source toolkit. And then the very first element here is the model. So the reason why it's a little bit ugly, because it's taking the model object from the last step of this CLF pipeline. So basically this is nothing but the model. Then I pass some background data or training data. And the other three elements or parameters are optional. I can pass the feature names so that I see the feature names in the visualization dashboard rather than feature 1, 2, 3, which is not that human readable. I also can pass what class names or class codes mean, 0 rejected, 1 approved, so that I see these words in the dashboard. We'll review it together real soon. And then the last thing that is sort of unique to our offering is you pass the transformations, the feature transformations that you had on top If you don't pass it, then the interpretability technique will return to you the explanations in terms of engineered features, which sort of defeats the purpose because it's not that human readable. But when you pass the transformation pipeline to us, then we can reverse it for you and return to you the feature importance values in terms of raw features, which were the features that you brought to this machine learning model. When you do that, it gives you an explainer object. You can call explain global, which overall explain what are the top key important factors impacting your loan allocation decisions. And you can see them in a dictionary. And then you can also call explain local on the explainer object, which is either you pass a particular data point, say Mehrnoosh's data point, and you see why Mehrnoosh's data point has been rejected or accepted. Or you can also pass a range of data points, like how about all the females in my data set? What are the top key important factors impacting their decisions? Now, what we are doing or we have added is also an interpretability dashboard. Of course, you can always export all this information into an Excel or CSV, but we really wanted to provide you with an explanation dashboard that can provide you with different aspects of your model, like a 360 view of your model performance, data set statistics, global explanation or aggregate feature importance, and also local feature importance, which we call also individual feature importance and what if. So let's go through it. Right off the bat, when I load the dashboard, it was actually just loaded with this main dataset cohort, which had all the data points. But what I did was I went ahead and I created 2 sub-cohorts because I want to know how the model has trained sex female versus sex male. And this dataset only has 2 sex, a female and male. But of course, if you have more than binary genders, you can also add cohorts for people who are not being sort of identified as female or male. So the very first tab, model performance, I'm seeing the overall, what is the performance of the model, the probability of rejection, what is the median, 75 and 25 percentile, same for females and males. And I can also see accuracy across these data points. So something that captures my attention is for females, the median probability of rejection is a lot higher than males, and also the results are a lot more consistent, hence the length of this chart. So the both 25th percentile and 75th percentile are higher than males. The interesting part is, so basically women are getting more probability of rejection. That's something that is a little bit worrisome. I would like to investigate it further. The other thing is the accuracy of my model is almost 12% more on females compared to males. Makes me a little bit suspicious that maybe females in the ground truth or the actual truth labels of females, there was not enough representation of people who actually had the ground truth label of rejected versus approval. So that's something that I would like to investigate when I come to Dataset Explorer. So I would like to investigate the ground truth values. So that's what I will fix it to. And now I can go quickly between females and males. And as you can see, if you compare this length of males versus females, it's less than 1/3 basically. So we had a lot less representation of females with actual ground truths of approved. So that explains a little bit why the model performance has been much better for females, because even if randomly the model says rejected for everyone, it's still gonna get a higher accuracy because a lot more people actually had the actual ground truths of rejected. The other thing that I would like to investigate is what are the top key important factors impacting my model my model explanation. So how the model has come up with its predictions. So for a second, let me turn these 2 off. So for all data points, I can see that marital status, education, occupation, and capital gain are the top 4 important factors impacting my model prediction. Now, let's click on one of them and see how education is impacting the model's prediction. In this dependence plot, once I click on education, I can see the education value of features on the x-axis and the importance of education towards class rejected on the y-axis. So what does it tell me? It tells me that as people had higher education, hence moving to the right side of this chart, then higher education became a negative indicator or predictor of prediction rejected, or positive indicator of accepted. So for highly educated people, the model tends to use that higher education as a positive indicator of getting approval on their loans. Now that I saw that, I would like to see whether the situation is the same for females versus for males. So I bring them back and I say, how about females? I sorted by females. What are the top key important factors for females? Right off the bat, I see a very major problematic signal. Sex is the top second important factor for females. And as you can see, it's non-existent for color green, meaning that it's not important for females at all. So when I click on the overall sex, I can see that sex 1, which in this data set is males, plays a 0 role in predicting someone would get rejected, but sex 0, which in this data set is equivalent of female, for females, the fact that they are female plays a positive role towards the prediction rejection. So this is really problematic. And the last thing that I would like to highlight is once you go to the last one, you can see all these individual points. Now I would like to just focus on females. You can click on a particular data point, up to 3 data points, see what are the top key important factors impacting. So this particular person, for instance, is true class rejected, predicted class rejected with 65%. And her sex has been the top most important factor in prediction of rejected for her, which is again very problematic. And then the work class value 2 has been the top second important factors towards the rejection. You can also see what factors could actually help her get approved, but maybe the other factors were a little bit winners, so the person has been predicted to get rejected. So I can do a little what if analysis here. What if the person was actually a male? And unfortunately, oh yeah, actually it's connected. So as you can see, I literally, the only thing that I did was nothing about financial competency of the person has changed, but I just switched the gender or sex of this person from female to male, and the prediction changed from rejected to approved, rejected 65% to approved to 62%. So this is another flag for me, because this is what if analysis in general is a great tool for debugging and saying, oh, what if this happened? What if this happened? And then do this what if analysis and see whether your model is basically doing what is intended or what intuitively you're expecting it to do. So now that we observe this, I'm getting back to my sample notebook. And I would like to load the Fairland dashboard, because now I'm really worried about how my model is treating different sexes, female versus male. And I would like to have a more formal way of assessing how the model is predicting rejected versus approval. So I call the dashboard and I pass the metadata that I need, in general predictions of the model, the ground truths. Right off the bat, when you load this dashboard, you can see that there is this basically cover page where it allows you to go through 2 rounds of configurations. You pick your sensitive attribute and you pick your performance metric, which is how you want to really evaluate your model. So let's get started. I move forward with sex because that was the thing that I observed with the interpretability dashboard, which was the red flag. Then I would like to, this is a binary classification model. I would like to choose accuracy, which is the fraction of data points classified correctly, as my way of measuring the performance of this model. Now, when I hit next, I finally land on this result page. What I'm seeing. First, I'm seeing the overall accuracy of the model, because if you remember, accuracy was the performance metric that I chose. So 84% accurate for my model, for all overall data, 92 for females versus 80. If you remember, we saw this disparity and difference between accuracy in the interpretability dashboard as well. And we observed further and we realized that the female dataset was a lot more diverse to begin with, hence explaining the higher accuracy that we got for females. The other thing that is way more related, so here you can see the disparity in accuracy. For females, the model is 12.3% more accurate for females. The other aspect that is a lot more relevant to the concept of fairness is you can see how much under prediction versus over prediction your model has assigned to males versus females. For under prediction, we mean predicted is 0, true is 1, so it's basically false negative. And for over prediction, we see that the prediction value is 1, but the ground truth is 0, which means that it's basically a false positive. So my model is getting a lot more false positive for males, but also a lot more false negative for males. So depending on my context, on the domain expertise of the person who is looking at this, they can decide what is the problematic signal that they're seeing. But the other thing that they're seeing here is overall 19% of the overall population have been selected to get the loan, but when you break it down between females and males, you can see that 24% of males have been predicted to get the loan, but only 7% of females have been qualified to get the loan. So there's a disparity of this minus this, which is 17.7% disparity in selection rate when it comes to treating females versus males and providing the favorable outcome to them. Talking to a lot of banks, this has been a deal breaker for them because due to regulations, they might come and check and they're like, wow, your model is 17% providing more favorable outcomes to males compared to females. So at this point, you can go ahead and augment and enhance your training data, revisit your data collection process, revisit your model training process. But after you do all of these, if for any reason these statistics are not getting improved, then you can come to us and use our mitigation techniques. In this case, I'm using one of our many supported mitigation algorithms called grid search, which is state of the art out of Microsoft Research New York City. And the way that it works is you pass your learner, in this case, if you remember, I had my learner was logistic regression, and also you pass a fairness constraint, which is how the algorithm should mitigate the unfairness. So demographic parity says the percentage of people getting favorable outcome should be the same among different sensitive groups. So basically, it's reflecting that this 17.7% should be improved. After we use this grid search, I fit the model again using this grid search. And after that, I get rid of some non-dominant models. So I just, because the way that grid search works, it basically goes and reweights and possibly relabels your training data and calls your learner. And it does it multiple times, and each time it provides a brand new model to you, hoping that because we have passed this demographic parity constraint, it's hoping that the demographic parity, which is really disparity in selection rate, is decreasing. So it does it very intelligently with respect to this constraint that you have passed. And by the way, we support 4 or 5 different constraints, so you can feel free to take a look at fairland.org to understand basically what type of constraints we're supporting. Now that I've done that, I load this dashboard again, and then I go through the exact same configuration. And what I'm seeing right now is basically I'm seeing my original model. This is accuracy of the model versus disparity in selection rate, which was really the promise of using demographic parity to decrease this. So if you remember, my original model was almost 17% disparity in selection rate. Any other mitigated model, except for this one, the other options that a grid search has provided to you have a little bit less accuracy, but they have improved the disparity in predictions quite a lot. So in that case, I'm like, this is my unmitigated model, which if you remember was this. So going back to the multi-model, I'm okay losing the accuracy with only 2%, but saving a lot on disparity in accuracy. So I click on this mitigated model and I move forward to see the disparity in selection rate, and voila, basically from 17%, I could decrease the disparity in selection rate to less than 1%, which is of course a very huge improvement over what I had previously. Again, this is completely context driven. As a stakeholder, I look at this model, I decide whether that's something that I would love to move forward with. But something that I want to quickly highlight is the Azure ML integration of it is you get this connection to the Azure Machine Learning workspace, which is basically this whole area where you where it keeps all your experiments, your models, your assets, everything. So now I created one, and basically what I'm doing is I'm registering all my models that I just trained, or the mitigated models and also the original model. And after that, I upload the fairness insights that I have using upload dashboard dictionary. I upload every single fairness insight that I had generated using the open source offering, and I upload it to the Azure Machine Learning Studio. And after that, I also can upload the model explanations to Azure Machine Learning. So this way, when I go to my Azure Machine Learning Studio, which is ml.azure.com, and I really recommend you to check it out, and I click on my particular experiment that I just run and a particular run under that, I see two tabs. So one is the fairness tab, which basically shows you the exact same dashboard that you just saw from the open source, but this time in Azure Machine Learning, and you can easily share it with other stakeholders. So let's, yes, exactly. So basically, I can do the same thing, and that provides me with a bunch of insights. And then this time I chose race, so I can see the disparity in race among different races, or the disparity in performance among different races. So this exact same thing, but also you can go to the explanation tab, and the same dashboard that you just observed is also going to show up within Azure Machine Learning. And this way, you can basically learn what are your model explanation, how it has come up with its prediction, and share it with your stakeholders. And these experiments basically live here forever. So you can always go back, click on your experiments, and share and look at something from the past.
Thank you so much.
Thank you so much.
I think, okay, I was hearing some echoes. Yes, I was saying thank you so much, Merce, for all these demo. And actually, I was getting a lot of questions, so I was also, taking some notes for myself for some of the questions that people were asking. You mentioned in this demo the grid search mitigation algorithm, and you mentioned that this was a work done by Microsoft Research New York. So one of the questions that I got is, how was the work like? The type of integration that your team, the product team, was able to do with some of the open source tools that were developed by Microsoft Research. Like, I think that it's more like a general question, like how was this type of collaboration, and do you have, what are the next plan? If you can share something related of what's the future plan, and if there are additional interpretability or fairness techniques that your team is planning to include in Azure Machine Learning. So this is, I found this question great, so that's why I'm asking right now, immediately after your demo.
Sure, I can address that a little bit. So basically, both of these offerings, interpretability, Interpret ML and Fairlearn, is based on a lot of wonderful research that either our researchers within Microsoft Research or some very, very known researchers out there in academia or other industries have worked on. So we strongly believed in responsible AI should be open and should be open source, so that people build trust with the algorithms and techniques. And for instance, in case of Fairland, because you just mentioned it, the Fairland repo came out of a research of two of our great researchers, Miro Dudik and Hannah Wallach, as a basically to accompany the paper that they published to represent these interpretability techniques. Then that was when we came into the scenario, and we had received a lot of feedback from our customers that they're struggling to get AI right, and in general, fairness is such an important challenge when it comes specifically to a lot of regulatory spaces. So we partnered with them and expanded this Fairland offering to not just include mitigation algorithms, but include assessment, dashboard, also mitigation in a very optimized way, so that people can use it in real-world scenarios. And then, because our team performs in open source first mindset, after we had a mature open source offering, we of course integrated with Azure Machine Learning, so that our Azure ML customers have access to the state-of-the-art techniques from the get-go. If you want to learn a little bit more about the history of how Fairland became a thing and also interpretability, there are two white papers that perhaps we can share the links afterwards, but if probably they search Fairland white paper Microsoft research, probably that's the very first link that they would see. And the other thing that you mentioned a little bit about roadmap, we are investing a lot on the great feedback that we have received from our customers, either on the Azure ML side or in the open source side. And some of them are enhancements to the dashboards to provide better offerings, more sophisticated ways of them interacting with the insights of the model, either performance, understanding the errors, understanding the data. And then also the other thing is a lot of industries basically provided us with this need for building real-world use cases end-to-end and showcasing how these, for instance, can be used in a healthcare scenario or in a financial scenario. So we're also working on a lot of use cases. So and some of them you probably will hear from us in about 6 months or so. So definitely stay tuned for our events, because we will announce both InterpretML and Fairlearn offerings, mostly either through Microsoft conferences or in a lot of, say, ODSC and some other conferences as well. And because both of these are open source first, the open source roadmap we tend to put on the open source so that the community knows what we're working on. So please feel free to also check out and join if there is a working track that is interesting to you. We do community calls and user calls monthly and bi-monthly. So I would love to know if you want to join on board and maybe hack with us a little bit.
We look forward to it, really. You mentioned that you are planning, of course, also to develop multiple real-world scenarios. Regarding the demos that are currently available, some people ask me, where can we find these demos? So I shared the link, the GitHub repo for specifically the demo that you just shared with us, Mers, and I also shared the general Azure Machine Learning GitHub repo, just if they want to see, other wonderful demos related to automated machine learning and Azure Machine Learning in general. Do you have any other suggestions? Were there the right links or anything else?
Yes. Sure. If they want to use the open source offering, if they go to fairlearn.org and then go to the GitHub or interpretml.org, there's a sample notebook folder in both of them. They can play with it. And the other thing I wanted to mention is in the Azure Machine Learning docs page that you had shared with them, there is a concept part and there's a how-to part. And under both of them, there is dedicated places for both fairness and interpretability, both under concept and both under how-to. And they can click on there and learn about the specific parts of integrations. And it takes them to some sample notebooks on Azure ML, which is specific to how these two open source toolkits have been productionized with respect to Azure Machine Learning. So they can learn more how to use them in conjunction with Azure ML services.
I have been sharing all these links, so make sure to check them out and let us know also if you have any questions offline. So this is great. Honestly, I've been receiving many questions. So before we conclude these sessions, do you have any closing notes, Stephanie? Anything that you want to add to this, wonderful area that I'm so glad that the Azure Machine Learning team is investing and working on?
Yeah, sure. I guess the main thing I want people to take away from this is responsible AI is a complex space, and it really engages with broader societal issues. So there's software tools are not going to be like a one-shot or one-size-fits-all. So you really have to dig in, really understand the issues, and really learn the context. But I hope that the resources and tools that we provide you will help you get started learning, navigate the space, and really deeply understand it.
And beside all the links and the GitHub repos that we have been sharing today during this session, you also mentioned a few conferences. So, are you planning to attend or present any machine learning data science conferences in the near term, like meaning this summer. Of course, everything is going to be online because of the current situation. But you or your team, are you planning to attend any of these summer conferences?
Yeah, so there is a session that we have in Data Council online conference, which is Friday next week. So 30th or 31st, whichever it is. And then so that there we talk about similar topic of responsible AI, and we do demo, and we touch a little bit more on responsible AI in Microsoft, what is the vision, etc. Then there is a full day hands-on, well, it's not hands-on actually, it's more like research behind interpretability at KDD conference, represented by some of the biggest names in the world of research, and Rich Caruana, Scott Lomberg, and Marco Ribeiro, and their team members, people who are really behind SHAP, Lime, and Interpret ML and EBM. So definitely, if you're attending KDD online, feel free to check out the session, the full day workshop there. And we have a very active presence at ODSC conferences, both East, West, Europe. So we plan to present at ODSC Europe virtually this September as well. And of course, ODSC West, I believe it's in October and November as well. So I hope we
So
see you there
it
too.
sounds like a very busy schedule for these. So it's exciting. And by the way, I also really like the open data science community in general. And I'm so glad that they kept doing these conferences online. So this is great. So I have been sharing a lot of links. And I will make sure that I will keep. Cut and paste these links also at the end of the session. But I think people have been receiving a lot of resources, so we are fine from that point of view. I do want to ask you both some questions. I mean, I already asked you some questions. People were very interested in the open source nature of this work. So you already gave us a great overview of that aspect. Then people were very interested in the GitHub repo and in all the demos, some of the scenarios that you just shared with us. So that's great. Another question that I got is related to startups. So do you have any suggestions? So not only for big enterprises, but also for people who work in startups or who are planning to fund a startup. So how can they get started with responsible machine learning and make sure that since day one of their startup they are able to incorporate these principles and these toolkits within their solution? So basically the question is like, are you only working with the big companies for now, or you are also considering other business realities such as smaller companies and startups?
Yeah, I can.
Go ahead,
Mars. No, go ahead. Okay, I was gonna say that startups had a very unique and beautiful opportunity here because they're at the probably beginnings journey of their use of machine learning model. It's not like they have models in deployment for 10 years and now they have to go through every single investigation from scratch. So I really believe that's something that is extremely important, and given the fact that responsible AI is touching different aspects and different facets of a machine learning training, is really making sure when they are either collecting data or just even thinking about what data needs to be collected, all the way to training models, all the way to deployment, all the way to development and deployment, really make sure that they consider the people who are going to be impacted by these AI systems. What are some intended or unintended impacts? It's super helpful to bring very diverse group of people to the session, because of course if we only have, say, white males in the room, it's very difficult maybe for them to have this sympathy towards, say, a Black or African American woman or someone who is not necessarily sharing the same characteristics as them. So Responsible AI is about every single piece of an ML lifecycle. Every single piece needs to be documented, responsibly shared with other stakeholders in case someone leaves the company. The other person who takes that data, that model, or that deployment should know what are the limitations behind it, what are the best practices behind it. And the other thing that I really wanted to mention is basically all of these toolkits that we're building are completely open source and free. So they can incorporate it into their ML lifecycle from day one. It is a high time to move away from treating machine learning models as black boxes. So they should always have this mindset of, I'm going to use interpretability, understand how the model has come up with its predictions. I'm going to also use the assessment if it's relevant to their topic, fairness, and understand how my model is treating different demographics. Is that intended? Is it not intended? And try to come up with innovative ways of going all the way back to data training, collecting, cleaning, and try to address that. So for companies who are at the very beginning of this journey, I feel like it's a lot easier because they're not sharing a huge baggage from the past, so they can always start fresh. And basically, I feel like our community has come a long way, collective, not just Microsoft, a lot of different companies to put these great tools out there. So I'm hoping that it's a lot easier nowadays for companies to start innovating responsibly compared to the past.
And I really like this answer because honestly, you touch different aspects from the collection of the data, but also from the diversity that is important to have, diversity and inclusion that is important to have also in the team of machine learning scientists, data scientists, developers, and business analysts, everyone who is going to be involved in this solution. So that is also a very another very important aspect that we shouldn't forget to mention. I know that we are at time, so this was honestly a very, very interesting hour of my day today. So thank you so much for sharing, Stephanie and Mers, all your knowledge and your work with the customers, with different product teams and the research teams across, across the responsible machine learning field. This is very exciting. We all look forward to hearing even more. And thank you also for all the people who joined today. I shared a lot of resources here, and I have been, receiving great questions. I ask you most of the questions, and the comments that I'm reading here are all very, very positive, and people are very, very excited. So that's great. Thank you all again, and I hope to invite you soon to another, episode where we can eventually talk more about your work and also give people other additional demos. Thank you so much. Have a good night.
Appreciate it.
Bye bye.
you.
Thanks. Have a great night.